Okay, what are some ideas for how we might find the top?
Well, so we need to find, I think first we need to find two things. We need to find the coordinates of the center of the triangle.
Okay.
And we need to find the length, how far up it goes.
Alright.
So I think to find the center of the triangle, I'm going to write over here, we can use a right triangle. So this point's the center. This is 0, 0. And this point is halfway along this edge.
Okay.
So it would be 1/2, 0. Or if you wanted to add the third 0, you could, but we're staying in 2 dimensions for now.
Alright, nice.
So, well, we know that so we know this is 1/2 to start.
Yep.
And then I think this is a 30, 60, 90 triangle.
Okay, how come? What makes you think it's a 30, 60, 90?
Well, just because of how we're dividing it. Because when we divide it all the way, like from here to this vertex, we get two 30, 60, 90 triangles. So when we partially divide up this, we probably will get others.
Yeah.
Okay, so where's the 30-degree angle?
So that's it. It's here.
Alright.
So this lets us find our other sides relatively easy, and this is the one we care about.
Okay.
So in a unit 1, it would be 1 root 3 2, or 1/2 root 3 over 2 1. So we're basically dividing everything by root 3. So this is 1 over root 3 over root 3 over 3, and 2 root 3 over 3. Actually, there's another 1/2 in there, so it's actually going to be root 3 over 6 and root 3 over 3.
Okay. So we should check, does this work? So if we check the Pythagorean theorem, we get a 4th, then we get 3 over 36, so a 4th plus a 12th, and does that equal 1/3?
And
It does.
Okay.
Yeah.
Alright, so we know the coordinates of the top. We know 2 coordinates of the top point. We know the x is 1/2, and we know the y is root 3 over 6, and we need to figure out the z.
Okay. Alright, so I'm going to ask your brother to move on now. And now if we know those 2 coordinates, how do I find the z, how high up it is?
well, you could actually use the hypotenuse, because you know the distance from the center of the triangle to one of the points is root 3 over 3.
Yeah.
And since it's going straight up, this is a right triangle with hypotenuse 1.
Okay.
So let's see if we can draw that.
Okay, yeah, we got room.
There. So we know that this here, this is root 3 over 3.
Alright.
We know the hypotenuse is 1, and we call this x. So we can say that 3 over 9, so 1/3, which is root 3 over 3 squared, plus x squared equals 1. So x squared is 2/3. So this x is the square root of 2/3.
Yeah, you can just leave it like that. That's fine with me.
So now we know this distance up is the square root of 2/3,
Okay.
which is, just write that in.
Yeah, you can just write that in, square root of 2/3. That's fine. Okay, super. That's a really nice job, guys. One thing I just want to say, can I have the marker? So when I have our triangle here on the bottom is at 0, 0, 1, 0 and a half root 3 over 2. And then we found that the center had coordinates 1/2 and root 3 over 6.
Yeah.
So I had a triangle like this. So this was 1/2 root 3 over 6. This was 0, 0. This was 1, 0, and this was 1/2. Am I still on camera, by the way?
Yeah.
root 3 over 2. And the center turned out to be 1/2 root 3 over 6. And we did that by a Pythagorean theorem calculation. Can you see any other way to see that the center has coordinates 1/2 root 3 over 6 very quickly?
Taking the average of the coordinates.
All right,
Yeah,
so
if you take the average, you would find the center.
take the average will help you find the center. So the average x coordinate is 0 plus 1 plus 1/2. So 3/2 divided by 3 is 1/2. The average y coordinate, 0, 0, root 3 over 2.
And divide it by 3, that's root 3 over 6.
Yeah, so there's a, you have to be careful about which center of the triangle you're talking about. But this way, finding the center actually turns out to be pretty straightforward.
Alright.
Okay, hey, good job. All right, so now we're going to go on to the octahedron.
Alright.